Bismillahirrahmanirrahim. Today we're gonna start lecture number 6 for module number 2. As we were discussing about the different terminology about encryptions, okay, so today we're gonna start talks about the encryption equation, okay, how the encryption equation looks like and how gonna be represented, okay. So today there will be a representation of different encryption schemes, okay. So as you can see with the red color, there is a C equal to E, in the parentheses you can see P. So P here stands for plain text and C is for ciphertext and E is in a machine. Machine means like it is just like a equation, okay, or the process. So E is the encryption process on plain text which gives you a ciphertext, okay. And similarly you can see D. D is also a kind of a equation or a process, okay, which is applied on a ciphertext to get back your plain text, okay. So C represents over here is a ciphertext, E is your encryption rule, okay, the encryption rule or process or machine, or means you can give any name for your ease, okay, for understanding. P is a plain text and D is a decryption rule, okay. So here as per the book's rule, so we say D is a decryption rule and C is a E is an encryption rule, okay. So we will use the formal notation to describe the transformation between the plain text and the ciphertext, okay. So what we seek in a crypto system for which P equal to decryption within parentheses encryption and which is applied on the plain text. So if we imply the encryption on the plain text and then we apply the decryption on the plain text, so the null effect will be 0. So you will get back your plain text. In other words, we want to be able to convert the message to protect it from an intruder, okay. That is the main purpose, that how we can protect our message from the intruders, from the attackers. But we also want to be able to get the original message back so that the receiver or the recipient can read it properly. So this is a very general equation and you must remember this, because this equation will be used in all module in module 2, in the whole module, okay. This is very important. So C equal to encryption for P and plain text equal to decryption for ciphertext to get back the original text. Now we go for the next slide, okay. In the next slide we will have some more elaboration, more algorithms and more techniques, okay, and more terminologies. So the crypto system is usually the whole system for encryption and decryption. So it involves a set of rules for how to encrypt the plain text and how to decrypt the ciphertext. So this is very easy. Usually it was used for initially for the wars, okay, to send the secret messages to your colleagues or to your groups or to your brigades, okay, and to keep it safe from your intruders or your enemies, okay. The encryption and decryption rules called algorithms, okay. So the rules now they give a proper name, algorithm. So as I told you, it's an engine, it's a process, or now they call it as algorithm, okay. Often used as a device called a key, okay. You need a key. Key is very important and we denote this key with the notation K, so that the resulting ciphertext depends on the original plain text, the algorithm and the key value. So algorithm is important, you must have, and the key is hard. The most important is the key. The stronger the key, the stronger the algorithm or the rule or the process or your engine. So that the resulting ciphertext depends on the original plain text message, algorithm and the key value. We write this dependence as C equal to EKP. Okay, what do you mean by this C equal to E? C, as you know, is a ciphertext which is equal to encryption of plain text by the help of key, which is represented as a key, okay. So you need a pair set, okay. So the pair set or the pair set tell you about, you need in the pair set you have two elements which is called plain text and the key, okay, and on which encryption is applied, okay, to get a C. So this is a more generalized form of the encryption and a more mathematical form according to the set theory. This process is similar to using the mass produced locks in a houses, okay. So just like a locks for a houses, so similarly you can have a you need to produce like keys for your houses. Moreover, it says that expensive, every lock is designed separately. Of course, yeah, if you have different locks and different things, so that will be very expensive as well. Few well-known companies produce standard locks that differ according to the key. So they produce standard locks, okay, and but the keys are different. Okay, so the most important thing that if you produce the different locks for every system, so that will be very expensive. So what we have, the companies, what they do it, they produce the same lock, but the key is different. Uh, so the more terminology we have, cryptography means like hidden writing using encryption to conceal text. Conceals mean like to hide the text or to protect the text. A cryptanalysis is the opposite, or it is a reverse. It's a reciprocal, or it's a anti of cryptography. Means like just like to break to break the ciphertext. So cryptanalysis is studying the encryption and encryption messages, hoping to find the hidden meanings. Okay. So what is the hidden meaning? So this is for the hacker, this is for the crackers, and this is for the enemies, intruders. So cryptanalysis or for ethical hackers as well. Okay. Both a cryptographer and a cryptanalysis attempts to translate the coded material back to its original form. So that is the main purpose, okay? But the intention is different. So cryptographer intention is different, and analysis intention is different, okay? While the cryptanalysis is a little bit harder because you need to crack a system. But a cryptographer normally works on the behalf of the legitimate sender and receiver. Okay, so this is the good guys. Okay, cryptographer. Whereas a cryptanalysis work on the behalf of an authorized interceptor, means it's illegal or like on the hacker's side. But it can be an ethical hacker as well. Okay. Cryptology is a research into and study of encryption and decryption. So cryptology, when we use a word cryptology, so it is a research, okay, research on encryption and decryption. Okay. It includes both cryptography and cryptanalysis. So you can see that cryptology is a major element, and under which the cryptography and cryptanalysis comes. So we have concepts now. Now to just to give a summary of that one, we have a cryptography means hidden writing, encryption means encode or encipher, decryption means decode and decipher. Crypto system is a system of whole phenomena, how to encrypt and how to decrypt. And then we have a cryptographer is any person who invents encryption algorithms. Okay, you can also invent your own algorithm if you consider that it can be more secure, and you can find its strength and its performance as well. So two things are important: the strength and performance, how quickly it converts, or how quickly it encrypts and decrypts, and how strong it is, how much time will it take to break it. Cryptanalysis, anyone who attempts to break encryption algorithm. Okay. Cryptology, research of encryption and decryption, including both cryptography and cryptanalysis. Concept of symmetric and asymmetric encryption. Before digging deep into this concept, I would like to tell you that symmetric uses one key and asymmetric uses two keys. Okay. How the one key symmetric uses one key for opening and closing, or you can say symmetric algorithm uses one key for encryption and decryption. Now we come to the asymmetric. Asymmetric uses two keys, one for locking the door and another for unlocking the door. Or you can see one key is used for encryption and another key is used for decryption. So this is a small story about the asymmetric. So the asymmetric uses the two keys. Now we properly see the diagrams. If you see this diagram on the symmetric crypto system, you can see the same key. Only one key is used. The same key is used for the encryption, and the same key is used for decryption. So this is a very simple. We already discussed this diagram in lecture number 5. Okay. Now we have lecture number 6. Okay. Oh, if you see over here for the asymmetric crypto system, you can see over here for encryption you need a key which is called KE. KE is for means the key for encryption. Okay. While after it has been ciphertext has been converted, now for decryption we don't need the KE because KE is used for encryption. Okay, we need a KD. KD is used for the decryption. Okay, so we need two keys. One key is for encryption for locking the door, and another key for unlocking the door. Okay, for decryption. So KE here is termed as public key. Why public key? Because The public key can be with anyone. Anyone can encrypt your his own message. Okay, but for decryption, that can be the private key. The private key is only with the person who wants to decrypt it, and because if the private key is with everyone, so there is no benefit for keeping the message secret, because everyone can unlock it or decrypt it or decode it. Okay, so the private key is with the specific person, with the one person, while the encryption key is with the many public. So it is a public, it is with every person. So if you just read it, the proper thing over here, the encryption and the decryption keys are the same. So P equal to decryption for we need a K key, and for we need the encryption of plain text with the help of key. So D and E are the mirror images of processes. Asymmetric encryption and the decryption keys comes in pair. Okay, then decryption key KD inverts the encryption of key KE, so that here you can see over here, for encryption you need a plain text and KE, not KD. Okay, because KE, and for decryption you need KD. You cannot use the KE. So there is a difference. Okay, how to generate these two keys? This is another story. We will generate these keys in a coming slides. Okay, and how usually the keys are generated, and because there is a we need prime numbers for we need two prime numbers for generating of this key. So any two numbers cannot be an public key or private key, and the pair for making the pair there is a specific formula. Okay. So converting C back to P involves a series of steps and keys that are different from the steps and key of E. So this is just a formal definition of symmetric and asymmetric. Now let's see what we have in the next slide. Okay. Sometime computer will get hang, so let me see what is in the next slide.